Hello everyone, my name is Shane Millick, and this is a presentation about a project that I've been working on called Lazy Birder. And my goal for tonight is that hopefully some of you leave here with a couple ideas on how to put some Zap in your computer vision app. So within the past few years, I've developed a keen interest in birds, and quite often I see a bird and I want to know what species it is and some information about it. However, the problem is I simply just don't have enough spare time to become a bird expert. So my solution was to create a web app which could identify the species of a bird from a photograph. So I knew this would be a problem for convolutional neural networks, and I also knew that I needed a lot of data. So I found two primary data sources thus far that are really good, the CUV200 and the NA-BIRDS data set. Each one comes with thousands of images, and each image has bounding box information, so you can crop around the bird, and then I also squared it and pre-processing. I also used Keris's image data generator, which is a really cool tool that allows you to add some variation to your images in, randomly during training. Ultimately, the data set that I used was the NA-BIRDS data set because it offered a lot more images, which was pretty important. So my key takeaway number one is that more data is more accurate. Now this is probably obvious for a lot of you. It's kind of known in statistics. However, I thought it's pretty cool to kind of see in real life what kind of difference it would make. So 32,000 images versus 11,000 images resulted in a 37% increase in accuracy. So in terms of the convolutional neural network architecture, my strategy was to experiment, and I tried a lot of different things, built some from scratch, tried to get fancy in a library called Lasagna, and then I was going through the online Stanford course by Andrej Karpathy, and he's got a section on pre-trained networks, and in there he says, don't be a hero. There's no need to build a neural network from scratch or train one from scratch when you can use a pre-trained network. So I tried a few different pre-trained networks. The one that worked best for me was the VGG16. It was introduced by an Oxford team in 2014. It's known for its simplicity. The beautiful thing about pre-trained networks is you can take a known architecture that works well, and also the weights have been fine-tuned on ImageNet, which is just a massive database of a lot of images. And it led to some pretty good results. So ultimately, I trained my network for 20 epochs, took over 48 hours, and I got 83% accuracy on my holdout validation test images. And I was really happy with that, considering my first model was about 12%. And I also looked at the top 3 accuracy, which was 94%. And that's basically where the correct bird was within the top 3 most likely species predicted. So key takeaway number 2 is that pre-trained networks are awesome. They're already optimized to recognize things like color, shapes, contours. There's no need to rebuild the wheel. And this resulted in a 68% increase in accuracy for me. So that was the end of my Galvanize data science program capstone project. But I wanted to kind of make it a little bit better. And by that I mean to integrate bird detection and auto cropping. The problem is if you gave an image that had, you know, a small bird in the frame and a lot of background, it wasn't very accurate. So for this, I found the TensorFlow object detection API. It was just recently released. It's really awesome. It's kind of got some out-of-the-box stuff that you can do with it. And I wanted to embed this in my PDF, but I couldn't figure out how to. Anyways, this is a GIF. I'm just looping through images of birds, and you can see how the object detection will identify the bird, and then you can get the bounding box information and then crop around it, and that really improves accuracy. So key takeaway number 3 is that object detection adds extra oomph. Auto cropping improves accuracy, and then also if no bird is detected, you don't have to, you know, predict an image, where before I'd upload a picture of myself and it would predict, you know, wild turkey or something like that. Okay, so I'll do a quick demo of lazybirder.club. Hopefully this, all right, perfect. Yep, so this is lazybirder.club if you ever want to check it out. Here's your homepage. Here's where you can upload an image. Got a nice quote about birding. Some information on how the web app works. Got some references here. And you can donate to bird conservation. So I'm going to go ahead and just do a quick demo here. So I'm just going to upload an image Now, I chose this one because it's a good example. You see here, there's a really small bird in the image or the frame, and there's a lot of background. So that's going to add a lot of noise, and it is not accurate at all without the object detection. However, I've got that TensorFlow model cropping the image before feeding it to my neural network, and then you can see here the results are pretty accurate. So 98% likely a solitary sandpiper. And you can see a little preview of the image that actually got fed to the network here. Now, if this wasn't, such a high percentage, you're not sure, I do return kind of the top 3 most likely species in this carousel here. And then you can also click to view more details, little bio, conservation status, pictures, and some links to more information there. All right, so my name is Shane Millick. This was Lazy Birder. Thanks for listening, and any questions? Oh, yep. And my appendix here, excuse me, my tech stack here on Lazy Birder.
Any questions? Here is the network architecture slide.
Yeah, absolutely. So yeah, so the VGG16, there's 13 convolutional layers, followed by 2 fully connected layers, and then 1 softmax output layer. I modified the fully connected layers a little bit. I brought them down in size, mainly because I was having memory issues on AWS, and it was like millions of parameters in RAM. And yeah, so it's this was the one, I tried the VGG19, I tried ResNet 50, I didn't try any others so far. Pretty much, yeah, just the 2 at the end. I think I messed with dropout, the dropout percentage a little bit in a few places.
More questions? Not that scary.
Anyone else? All right, I'll also say that I am also looking for a job. If anyone has any leads at all, come find me. Oh, yep, question.
Are you offering him a job?
I'll take it. Just kidding.
Does this thing look at the metadata of the picture to say, as this picture at this location, this group might not exist?
That's a good question. No, I haven't gotten that advanced yet. However, that's definitely something that I'd like to improve on, is looking at the region and the most likely region based on the time of year.
I have an avid birding friend,
Uh-huh.
and I have a feeling that she is going to potentially bombard your website.
Oh yeah.
But along the same lines of your question, I'm wondering, are there certain regions or species that you just can't detect?
Right, yeah, that's a good question. I didn't really specify. So I used only 200 species for my model. The database that I ultimately used has 404 species. I stuck with 200 because that was kind of where I originally was at with my first database. And also I tried the full data set, the full 404 classes of birds, and again, had memory issues on AWS. So it's really only 200 species. If the species isn't recognized, it just predicts what it thinks is closest, yeah.
That was really awesome. Thank you.
Cool. Thank you.
So at this point, we're doing something new, and we have a little lavalier mic for our audio review. We haven't tested out actually doing the back and forth between the 2 lavaliers that we chose. So you get to see Blair basically dress himself. In case you can't tell, we're pretty goofy here. How does that? Did it turn back on?
I was just making sure my stop little thing was going.
Oh, you are set.
Hello. This one's not working. Maybe I don't know how to work a mic. On. Hey. Hello. Hey, look at that. Cool. Hey, everyone. So my name is Blair Thurman. I am an alum of the data science program from Denver Platt. I also got my physics degree at CU Boulder last December, and today I'm going to tell you about my capstone project called the Reddit Nut Meter. So for those folks in the audience who aren't familiar with Reddit, Reddit is a social media website, and it's divided into these groups called subreddits, where you can talk about whatever topic you want to discuss. I like using Reddit to discuss my nerdy video games, but sometimes I run into these people who don't share my passion for discussing nerdy video games, and in fact, they're just kind of nuts. And they're not nuts in the way that they say jibber jabble that doesn't make sense, but I mean they're nuts in the sense they like to discuss things like this. And I don't know about you folks, but I don't really want folks who kind of are pro-white nationalists giving me their opinion on video games. I kind of just want to avoid them on the internet. So what I'm going to try to do is try to classify and label people on the internet just based on their comments that they make. And specifically, just to give a better definition of what a nut is that these are people who either use violent hate speech, so you can't just be racist, you have to be violently racist on the internet, and also defend sexual assault. So the way we're going to go about doing this is we start with all these comments, we're going to turn those into numbers, we're going to stick those numbers into a machine learning algorithm, and then we're going to look and see, did it do very well? So the first part, we're going to go and hunt down the data. And this was, I literally just went to terrible subreddits and just found these people manually by reading their comments. And if we went through together their comment history, you would agree that these people were nuts. And I found 40 of these people. And it took me over 2 days, by the way, to find 40 people. Very emotionally draining 2 days. And then I also found 40 other people who are just normal. They talk about cats or they food, whatever. And I just labeled them as normal people, kind of as like a control group. The problem with only using 80 people in their comments is that for my natural language processing techniques to convert it into numbers, it's just not powerful enough. I don't have enough vocabulary. So I needed to pull more words, but I didn't want to spend days reading these terrible comments anymore. So when you need more nuts, where do you go? You go where nuts grow. And so I went to these subreddits. Yeah, it's part data science, part comedy. So I went to these subreddits and I just started pulling people randomly. So if you were in that subreddit recently, I might have just pulled your data. And then I went to these other subreddits and I was like, oh, people who are there are probably normal. And so I just kind of assume these people are more likely or not going to be able to give me good vocab for my NLP, natural language processing techniques. So the part that we do to take them from words and put them into numbers is we start with something that's kind of messy, blah, blah, blah. We clean it up a little bit, so you lower it, get rid of the capitalization, excessive punctuation. And then we set it into our first NLP algorithm called TF-IDF, and that stands for Term Frequency Inverse Document Frequency. Not important for you to know that. But what you should know about it is that TF-IDF quantizes the importance of words to comments. So knife might be really important to this particular comment in this example. The next part is we need to figure out the topics that are going on that people are discussing. So this next part, oh, it's a typo. That's supposed to be NMF, not LDA. Don't tell anyone. NMF stands for non-negative matrix factorization. What that does is it not only finds these latent topics and these mess of numbers now, but it also assigns the importance of those topics to those comments. And so we might look at this comment and we say, oh, the most important topic to that comment is bomb. And so we label it as that topic. So what have we accomplished? Everyone used to be a string of comments, and now they're just a bunch of numbers. And what we can do with that is we can aggregate how much people are participating in certain topics, and then we have a new heuristic to define these users. So instead of having to define them as all these huge numbers, we just say, oh, that's how many times they're posting in these topics. And now they're just represented as a single vector, which is really awesome because now we can start setting these vectors into predictive models, and we can start trying to figure out if we can teach a machine to learn what is a, looking at these little vectors, can it figure out what is a nut and what's not a nut, and can it differentiate? So the way we do this is, in data science, there's a lot of algorithms that do classification. I'm not going to tell you about what those the differences are, but I'm going to use a random forest classifier, and in Python, you instantiate it, you put it into train mode, and you dump all your data in it. It's that simple. And then you turn it into test mode, and then you want to figure out, oh, well, now that I have new data, what's the probability that people are going to be nuts? So I went through the painful process of finding 10 more crazy people and 10 more normal people, and I tested on them, and I wanted to see what it did. So I dump it in, and it spits out a bunch of percentages of whether or not it thinks it's a nut. And so I have to ask myself here, what percentage should I label a nut as? Is it 50%? Is it 75? What is it? And the answer to that question is whatever percentage works best in my classification. So when I actually went through all of my models and I went through different thresholds and I tested all of the models to figure out which one's the most accurate. The best model I was able to get was this, had these statistics behind it. It had a true positive rate of 90% and a false positive rate of 10%. And you can think of false positive rate and 10% as, sorry, false positive rate and, let me try that again. You can think of true positive rate as the rate of which I'm right when I say I'm right. And false positive rate is the rate of which I'm wrong when I say I'm wrong. Yes. And so these numbers look good on paper, but let's think about this for a second. If I have 100 users in a given population, let's assume 10 of them are definite nuts. My algorithm will find 9 of those 10 people correctly. However, it will also mislabel 9 of the 90 people, so that when I am done analyzing this population, it's going to say there are 18 nuts in this population when it actually missed 1 and it mislabeled 9 people. So is that good? Is it bad? I think it's good because this was out of the bag. I barely did any tweaking. I had a very minimal set of data and I had 2 weeks to do this. So right now it's in a proof of concept phase. Thank you. So right now it's in kind of this proof of concept phase, but there are ways we can make it better. So the most obvious blaring way to make it better, it's a pun, my name's Blair. Normally people get that in the conversation, is we can get more nuts, so more data, and that's gonna much improve our algorithm like Shane was touching on. Beyond that, there's some other features I can include because I was only doing raw processing of the text. I can include the subreddit that it was made in, so maybe if it's in National Socialism, that might be an indicator that might be a bad comment. I could tweak that heuristic that I made, that vector. I could kind of make it a little bit different because I just kind of slapped it together and wanted to see if the machine would work with it. And then there's this idea of karma, and karma is just the net upvotes and downvotes a community gives a comment. So if I went to National Socialism and I said, all Nazis are bad, and they downvoted me, that's information that the thing would want to know because that's a negative comment for the community. This is my tech stack, and here's my face and some contact information.
Where's our questions for Blair?
Yeah, have you thought much about whether the subreddits are actually taking the data from maybe biasing your results a bit? Is it like maybe have different words you can put over top of the subreddits based on?
Yeah, it's a great question. And the reason, and you're talking about when I just pulled those 200 people from each, just kind of randomly, right? That was done just so that my NLP could learn more words. And so I kind of just needed to get any kind of words in there. And it doesn't really train and classify on those words. The only time it's actually classifying is on the labeled data. Those 40 users, the other 40 users, and the other 20 that I labeled in the end. Those are the only ones who see the predictive model, which is where that bias could be introduced. Does that answer your question? Fantastic.
The data science teacher here, Gavin.
So let's say you trained your MMF on balance, you know, you have the same amount of non-nuts, is that correct?
I'm sorry, what was that?
So you put the same amount of nuts and non-nuts in your MMF. What about when you actually ran the classifier? Did you find that the results were balanced, or did you find more nuts or less 50%?
Oh, so you mean like when I was testing?
Yes.
I mean when I had those 10 nuts that I had labeled and the 10 normies, I was called normies. When I had those folks labeled, it got 9 of those 10 correct. And then it, obviously mislabeled one of the other 10 incorrectly, which is where those 90% and 10% statistics are derived from. I don't think that's what you're asking though, is it?
No, I was just asking if you actually experimented and find the proportion of actual nuts that there are on Reddit or not. You just kind of put balanced class picture thing the whole way through.
Yeah, I would like to kind of analyze Reddit a little bit with this. If I kind of tweaked it, made it a little bit better. I haven't done that yet, but hopefully it's not 10%, right? Hopefully it's less.
I'm wondering, do you actually use the tool now on your Reddit usage to identify nuts?
The answer is no, and I have a good reason for that. And the reason is because what I just showed you is 2 weeks of work, and I have a presentation now that I've given 4 times, and so I have a pretty good way to talk to employers about like my skills as a data scientist, and so I kind of want to keep the project where it's at right now, and I've also started evolving into other classifications for a company that I'm using a contract for right now. So everyone wants me to kind of like put a web app up, but I just haven't gotten around to it because I kind of like that this is what I can do in 2 weeks, and people think, oh, that's neat.
Since we have so many people that are new to Analyze Boulder, of those new people, are you guys familiar with galvanized data science stuff? How many are not? Can you raise your hand? So few. Okay. Feel free to ask questions afterwards. I won't interrupt you.
You can also bother me. Any more questions?
This first one was the exact same as the first question asked.
If it's not controversial, what were the topics that were most noteworthy and topics that were least noteworthy?
I've got a slide for that. I'm going to warn you. So there aren't terrible racial slurs in this thing I'm about to show you. There is the F word, so I hope you all are comfortable with seeing that in text. So this is a word cloud of a topic that was one of the most nut-worthy topics. And so when I said earlier that that topic was a bomb, there's actually nothing going on in the machine learning that's actually figuring out what these topics are. That's my job. In fact, I actually wasn't even interested in figuring out what the exact topics meant because I just wanted to figure out topics that differentiated users. So I didn't dive into them too much. But because I knew everyone was curious about these terrible dark places on the internet, I made some word clouds and spun them up. And yeah, so when I looked at, this came back with this number, 0.74, don't worry about that, but it's very nut-like topic. And as you kind of go through here, you see a lot of things about just race, things that are pertaining to sexual identity, and curse words, but curse words are not always indicative of whether or not it's a good or bad topic. You get them everywhere on the internet. I'm sure you're probably aware of that. Great. Well, thank you so much.
Anita has a live demo, essentially, that she's going to watch the back of her report. So, no, we're going to bring it. So I wanted to ask this question earlier, and I'm just going to take the time to ask it now. Did anybody travel somewhere for the eclipse? How many? Not as many as I thought. Where did you guys go? Who went to Wyoming? I went to Wyoming. Who went to Nebraska? Who went to Idaho? One guy went to Idaho. That's dedication. Who couldn't go because of work? Ask work.
You guys almost ready?
Yes. Let's see. So something that we started that's fairly new is I've been noticing, you guys probably noticed this too, but there's a lot of introverts among us. How many people are extroverts?
Okay.
There's like 3 people to answer. I'm not going to ask them introverts because no one's going to raise their hand.
Yeah, is that okay, right?
So what I started to do was put up a slide
Okay, and
towards the end.
okay,
while we're just
it's
so
on
we
right
have
now, right?
Something to talk about. Just to sort of force you to be like, hey, we're supposed to talk about this, so what do you think? It's been working pretty good. I'm just going to give you a precursor since we are not ready. So we're ready now.
Yes.
Be ready for a topic at the end of this.
Hi everyone. So my name is Anita Khedkar and I recently joined Vertipore as a software engineer. Before I get into my project, I want to tell you about my journey with coding, and the reason being that that's how you'll find out the reason for my project today. So I did my master's in math and computer science in '98. And after being a developer for 2 years, I chose to be at home with my kids as their primary caretaker. And so for the last pretty much 2 decades, I was at home as a homemaker and a math teacher. And now the kids are older, they don't need me anymore. So I thought, why not get back into technology? But obviously everything had changed around me, and so I needed to know the latest and the greatest, and so Galvanize was an easy choice for me. So I actually just graduated from the Galvanize Immersive Web Development Program from the Golden Triangle campus. So for people who are here at Galvanize, you know that this is not easy. It's pretty tough. So you come here in the morning, go back in the night. After that, I was doing technical talks, going to meetups, had 2 kids, 1 dog, 1 husband, and doing a lot of chores. I just felt the need to specify that, okay. Where you're doing plenty of things, shuttling around a lot. And so in our household, everything started, all the chores and the things to be done started getting pushed to the weekends. But there was a problem with that, because every time throughout the week, I would remember all these things I had to do in the weekend, and the weekend came and I don't know why, but I would blank out and nothing got done. So I really needed help. And so I thought, what better use? Then, I wanted to customize the Amazon Echo and make a customized skill to help me with all these things. Most important, my short-term memory problem, manage my grocery list, chores list. And so that's what I did. Now, unfortunately, I came in late and I couldn't set it up at the front of the room. So I'm going to go to the back of the room to give you a demo of how my skill works with the Amazon Alexa. All right. And I hope it works. Alexa, open my list helper.
Welcome to Miles L for Skill. I track your grocery and chores lists. What can I do for you?
Add sugar to Costco.
Sugar has been added to the Costco list.
Add rice to Costco.
Rice has been added to the Costco list.
Add honey to Costco.
Honey has been added to the Costco list.
Add bread to Target.
Bread has been added to the Target list.
Give me my Costco list.
This is your Costco list. Sugar, rice, honey.
Add laundry to my chores list. Add laundry to my chores list. Alexa, open my list helper.
Welcome to Miles L per Skill. I track your grocery and chores lists. What can I do for you?
Add laundry to my chores list.
Don't bother. That is what husbands are for.
I know, she was like ditching me at the last minute, but so, oops. So, as you can see, she's not only a helper, she's become my lifelong friend now, because she knows exactly what I think. Yeah, so anyway, so this was, again, we all have 2 weeks to finish our project. So pretty much that was done in 2 weeks. That was my capstone project for my web development course. So behind the scenes, this is what is happening actually. So when we give a voice, when we use the wake word, that is Alexa, and we give a voice command, Amazon Echo sends the command to the Alexa skill kit. Alexa skill kit right there is using automatic speech recognition and natural language understanding, and it changes your voice command to text and sends it to Lambda. That's where my code is sitting. So Lambda is pretty much the one who's connecting with DynamoDB. That's the database I had used, and the email service. And when it makes a response, it sends it back to the Alexa skill kit. Alexa skill kit again takes that text response from Lambda, converts it to voice, and sends it back to us. So on that note, I also wanted to say that, not only does she give me back the list, she also sends me an email every time I ask her for a list. And so, I don't have to pretty much write it down. I can just print the list and go to the grocery store and get it done. So that is what it works. And now this was my technology stack that I used. So I used Amazon, web services, Alexa Skill Kit, the Lambda, DynamoDB for my database, SES for email services, JavaScript, Node.js. The skill is not done yet. It's not complete. I was really hoping to get it into the the Alexa Skill Store. And also email is done. Unfortunately, I can't show it to you because it's on my machine, and I was opening his Gmail when I tried to open it here. So, and I wanted to make it time sensitive. Like, I wanted to remind me if I have a bill to pay on Saturday, she needs to tell me. Also make it for each family member so everybody gets to do the chores. So those are my future plans. And that is it, actually. This was my customized skill. Again, my name is Anita Khirkar, and would love to be in touch with all of you. Thank you so much for listening. Oh, yeah, absolutely. Yeah.
Who's got questions for Anita?
Yeah.
On your future slide, you said that have a tour list for each family member. Would Alexa be able to tell who's talking to it and automatically generate a tour list?
I'm sure the speech maybe, I don't know, actually, I shouldn't say, I don't know, I haven't looked into it. I meant to say I can assign it to everybody else. So that was my thing, that I could at least tell Alexa that this is for, for the kid or whoever it is for. So just, yeah. Thanks. Yeah, sure.
Let's say if you add something to the list, let's say that it goes back and look at price discovery and then decides which place you should go. So you said Costco, Target, and then Amazon, of course. It says, okay, I want to order honey. Oh, looks like Target has a sale on honey this week. Go pick it up from Target and put it on that list.
That'll be super cool, actually. Yeah, and actually Amazon does have the shopping skill. So there is something like this that does exist on a larger scale. This I just wanted for my specific thing. So, Amazon also gives me a list of all the stores maybe in the entire United States, but I did not use that because I wanted to customize it for my needs. So I have about 10 stores there, and I just tell it, basically to give me back those lists. So on a daily basis, whatever I use, so that skill set was that. But I love the idea though.
So something that I noticed was that you didn't have to keep saying Alexa because Alexa did this, and that is one of my most frustrating things.
Yeah.
Literally,
I know. Yes. Yes.
I'm sorry.
Yeah.
So I wanted to slap Alexa.
Yeah, that was very irritating when I was testing it too. Oh my gosh. Yeah, actually it failed on my actual capstone project. She didn't work because somebody tripped over the wire. Luckily, I had a video of everything, so I just showed them the video and it was done. So it was good. Yeah.
Thank you so much.
Thank you, Tony. Thanks a lot. Oops.